So they, in the out of class exercises for S2, they presented two line graphs. One was one that was used by a news outlet representing the unemployment rate during the year 2011 for labor statistics. And that graph was criticized by Media Matters, saying that another line graph should have been used. Now, both of them, here was the news outlet used one that went from 8% up to 10%. The largest value was about 9.2, and the lowest value, I believe, was 8.6. And it fluctuated up and down from there. The one from Media Matters, they said it would have been more honest, since the data went from 8.6 to 9.2, to have a graph that was 8.6, 8.8, 9.0, 9.2, to have a graph that looked like this. They said that would be more honest to have. Well, from what we know, what can you tell me about how honestly both of these display the data? Is either one of them the best display of the data, I should ask? Okay, very good. They're both accurate, but both of them actually accentuate the differences. And what did they do that makes them accentuate the differences between the numbers? Exactly. The scale. The fact even this one only goes from 8 to 10, you're narrowing down the scale to only look at the range of numbers. The more honest way to display this data would have been to have your scale go from 0 on up, so that this data would look something more like this. So you'd barely see any difference in it because of that, the way the scale is set up. Okay, good. The rest of that I thought was pretty straightforward. Did you guys have any other questions on the out of class exercises for S2? Okay. Well then, for today, the PNL for S3 presented a couple of different studies. One scientific study was on steroid use, and they analyzed how steroid use affected brain chemistry. And they actually did scans of the brain to see enlargements of certain areas of the brains or deterioration of certain areas of the brain in people that use steroids compared to people who did not use steroids. The second one was on antidepressants. But for now, let's start out focusing on study one. In S3 here, they start out talking about that study and how they're going to go through the scientific process. Did all of you guys get a chance to read through those studies? You have not read it? Okay, I'm going to give you guys about 5 minutes to read through. It's in, like I said, it's the preparing for next lesson for S3. So it's at the end of S2 there. Read through the steroid study quick. So I'm going to pause the recording, give you guys some time to look at that. It's important that you have some of the information so that we can follow the process. Let's take a look at what the information you've got out of it so far. First question, remember we talked about population, we talked about samples. So for this situation with the steroid use, and be as specific as you can, what is the population they are studying here? Okay, there's 150 male weightlifters that were considered, but is that really the whole group that they want to learn about? Remember, the population is the group we want to learn about, not necessarily the group we look at. The study started out looking at all male steroid users. Now, that is a tough population to look at because you have people that use steroids for athletics and for weightlifting and training, but there are also people who use steroids because of health issues, prescribed by a doctor because of asthma or whatever. So they had to narrow that population down. And in this study, they narrowed it down in a couple of different ways. One, they narrowed it down by age range. Did anybody catch what age range they're looking at there? 35 to 55, okay? And then they did narrow it down to weightlifters. So the actual population they're looking at here, the specific population that they ended up studying, even though they really did want to learn about all steroid users, they wanted to learn about the effects of steroids on the brain for all steroid users. What they ended up studying was 35 to 55-year-old male weightlifters who are long-term steroid users. So that is the population that they ended up gathering data to try to learn about. Now the sample, you mentioned 150 male weightlifters. They gathered information from 150 male weightlifters, but not all of them made it into samples. In fact, there were 2 samples that came out of those 150. Can anybody identify what the 2 samples were? Well, there were the heavy, long-term steroid users. So the ones that just, use steroids a little bit, they didn't bother using them. But there was another group that they used for a second sample. Did you catch what that was? Non-users, very good. Why would they have to study non-users? Perfect. It's called a control group. We have to be able to compare the test group to something. I mean, we can't just take the heavy users, scan their brain, and say, oh, their amygdala is this size or whatever. You have to have something to compare them to, or you can't really draw any conclusions. Why did this control group, do you think, have to be weightlifters? Yes. There are variables in every experiment. And what you want to do is you want to try to control as many as possible. I can't write today for some reason. So we want to control all but one. That one variable is the variable of interest. And that was, in this case, the effects of steroid use. So the variable that we were adjusting was whether they use steroids or not. Well, there's a chance that maybe long-term working out and weightlifting might have chemical effects or physical effects even on the brain. So they wanted to make sure that they eliminated that variable, that they weren't comparing weightlifters to non-weightlifters. They wanted the two groups that they were comparing to be as much alike as possible, where the only difference between them was that variable of interest, the steroid use. Now, in reality, you can't control all the variables. There might be somebody in that control group of non-users that has an enlarged amygdala for other reasons. It might be pot use actually causes effects on the amygdala. Other things, other over-the-counter medications and prescribed medications can have effects. There are physical differences, hereditary differences, genetic differences between groups that can have that effect. So just because they tried to control all those variables doesn't mean that it was controlled completely. So what that means is out of that 150, that group of 150, there were some that went into the heavy users. There were some that went into the non-users, but there's also most likely some that were light or occasional users. Or maybe they had used in the past and stopped, or they used it, tried it a few times or whatever. Those light or occasional users were eliminated. We didn't want anybody blurring them in the middle. So you can tell that, the number that were used for these samples, the very best would be that there were 75 each if there was nobody in the middle. But we know that had to be less than that because there were some that were thrown out. So what would you say about the size of this sample? You say each is less than 75 people. What'd you say? But if each is less than 75 people, that actually in some cases would be a pretty large sample. But if we're looking at all people that use steroids, probably somewhat small. In fact, one of the things they said in the study was that they were going to need to do what? Further study. This is a phrase you hear a lot when you look at medical studies. Further study is needed, or further study is required. This one actually is what they call a preliminary study. You look at medical studies? Yeah, I know it's not a real interesting topic to read through. Um, I'm sensing a touch of sarcasm there. This is what they call a preliminary study. And what that means is they were just trying to find enough evidence to decide if they wanted to study more. A lot of times they do preliminary studies like this because these studies can be quite expensive. Just the labor costs, the number of people that are required to perform the study and gather the information can be pretty expensive. So a lot of times they'll do a preliminary study like this with a smaller sample, gather the information. I mean, taking the brain scan can't be cheap to do either. Gather that information so that they can justify whether it is worth doing more study or not. And then, of course, at that point, that's when they can apply for grants. Okay, so the next thing we want to do with this problem situation is we want to break down this curriculum. I want to say textbook, but it isn't really a textbook. This curriculum breaks down the scientific process. This is actually found in question number 2 in unit S and module S3. And in the scientific process, they break down a 4-step process. Step 1 is to ask a question. So in this study, what was that question that they asked? What was the question they asked in this study? Well, they were studying for the effects of what? There it is, perfect. Steroid use on the brain. Now, again, they narrowed this down a little bit, the effects of long-term steroid use on the brain of weightlifters. 35 to 55 years old. The next thing is they want to look at what are they going to measure? They just said what to measure. Or what data to collect. And what did they do to collect data here? Exactly, the brain scans. Of who? They did brain scans of 2 groups, and it was okay, long-time users and non-users. Step 3 then was to summarize the data. And as they summarized the data, what did they find about the effects, the differences between the brains of those who took steroids and those who didn't? More specifically, what did they find about the amygdala in users compared to non-users? Perfect. More than 20% larger in long-term users than non-users. So the conclusion was what they conclude from this. Well, they concluded that long-term steroid use does what? Causes causes just the enlarged amygdala. Long-term steroid use causes amygdala size increase or increase in the size of the amygdala. Now, one thing, I use the word causes here, and I'm going to cross that off, and I'm going to replace that with is associated with. Now, the reason I'm doing that is, yes, they did find that the people who had used steroids long-term, heavy long-term use, had 20% larger amygdala than those that had not. But just because those two things are linked together doesn't mean that one caused the other. There could have been something different about those people that were heavy steroid users that caused them to do steroids that also caused them to have, the enlarged amygdala. Or it could have been the other way around. Maybe genetically, those people had an enlarged amygdala, and that enlarged amygdala caused them to be more prone to become heavy steroid users. So dealing with association, a correlation and causation, as we had mentioned before when we did modeling, we have to be very careful about that. Just because there's a relationship between them does not mean one causes the other. Okay, then the second situation with the antidepressants, I'm guessing you guys need a few minutes to read through that one as well. Okay, so if you want to flip back then to the preparing for next lesson, the second situation on researchers seeing promise and potential depression treatment. I'll give you guys 5-6 minutes to read through that quick, and then we'll discuss it. So now for this one, what is the population they're looking at? It doesn't really come out and say it, but it's kind of implied. Okay, that's what they did to them was the magnetic stimulation, but it is people with major depressive disorder. Do they define an age group? Okay, so that's their population. They want to learn about all people with major depressive disorders between the ages of 18 and 65. Now, of course, they can't study all of those people, so they took a sample. And the sample was what? How many did they take? They did 63, and now it's important that they were volunteers. Partly because it's unethical to force somebody to take an experimental medical treatment, as I'm sure you can see why. Oh, other thing is, I almost forgot the population. One other requirement to be part of this group is they had to have been on antidepressant medication for at least 6 weeks. Now, the reason for that, antidepressant medications take at least 6 weeks to kick in and have any effect. So they were only studying people who had been on their medications long enough for their medications to be working. Did they take anybody that was not diagnosed with a major depressive disorder? They did not. Why not? I mean, in the last group, they took some people that had used steroids and some that didn't use. In this case, why didn't they have to have a group that didn't have a depressive disorder? Okay. There were still 2 samples. It's just in this case, we didn't have the control group was not a sample without the disorder. The control group was a sample that still had been diagnosed with a depressive disorder, but how was the control group done here? There's 2 groups. One group received the magnetic treatment, right? The electromagnetic treatment. What did they do with the other group? They didn't use it on them. But what did they do to them? This is an important part here. Exactly. Okay, what it means, let me just write this: process, but no treatment. What that means is they did everything that the other group did. They went in, they answered the questions, they prepped them, they put them in the machine for 20 minutes, but they never turned the machine on. They had the machine make noise or whatever. They had something to make noise to simulate the machine working, but the machine never did anything. Now, why would they want to do this? Why would they try to trick this group into thinking they got the treatment? There it is, right there. That's the perfect phrase. In their head. Quite often, especially when you're dealing with a mood disorder like depression, quite often just thinking that you've received a treatment that's going to help you causes you to feel better for a short period of time. So the coming out of there and being interviewed, they say, "Oh yeah, I feel great. This treatment is wonderful." Well, this is somebody who didn't actually get the treatment, so it's in their head, and that's referred to as a placebo effect. And there's actually been a lot of studies done where they'll give a group of people sugar pills, telling them that is this new powerful medication that's going to eliminate their pain. And a half hour later, that group reports significantly less pain. It's the power of the human mind. So they have to go through that process exactly the same. But that person does not know whether the machine was actually turned on or not. Now, from the ethical side, it is disclosed to them before the treatment that some will receive treatment and some will not. And that they will not know which was which until after the study is concluded. They will be told at some point, but not until after the study is concluded. So they know going in that they're not necessarily guaranteed to be getting the treatment. Well, yeah, it'd be weird to get to the end of it and realize, no, you didn't get any treatment, but hey, you're better anyway. That would be the hopefully the good side. Or, oh, you didn't get any treatment, now you're even sicker. Yeah, there's definitely some moral issues there. You'd have to be somebody who is willing to try anything, I think, at that point. It's called a blind study. The subjects don't know if they receive treatment or not. So, like I said, if they're testing a new medication, one group would actually get the medication, the other group would get a sugar pill or something that looked just like the medication but didn't do anything. Now, there's something out there called a double blind study. In a double blind study, the staff doesn't know who receives treatment. So what would that mean? Well, that would mean that somebody sets up the machine and the machine has an on-off switch on it. So somebody else takes that machine and they might disconnect the on-off switch or take out the part that produces that magnetic wave and replace it with something that just sits in there and hums and makes noise. So the person that actually takes that machine, sits in the room with the people that are in the sample, may not know whether that machine is actually the one that works or if it's the fake one. So they don't even know whether they don't know whether they're giving a treatment to the person or not. Can you think of any reason why that would be important? That person might not even know whether they're giving a treatment to the people in the sample. They could accidentally say it, or even if they don't come right out and say it, they might say something that gives it away. Yeah, the stupid fake machine or whatever. Also, just their attitude. Their attitude of like, oh, okay, well, this isn't really the machine, so I'm not going to be quite as, professional or quite as, strict about how I do things because you're not really getting zapped in the head anyway. So there's worry about if you know who is in the control group and who is actually receiving the treatment, that you as the staff person might treat them differently. So that double blind is very important. Do any of you guys need a quick break? Okay, let's take a break and let's come back about 11:30 or so, and we'll start up again. Okay, it's that time, so let's get going again. So I'm looking at this situation here. Let's go through and define the steps. Step one, they had to ask a question. What was the question being asked here? They're asking what are the effects of well, we're still looking at the depression study. So look at what are the effects of the low field magnetic stimulation on what? Were they looking to really cure the depression or what were they looking to do? There you go. The effects of the LFMS on the mood of individuals with depression or bipolar disorder. Okay, so then what did they decide? What data did they collect? Well, what did they do to collect data, I should say? Well, some had a real, some had a fake 20-minute treatment, right? So then the results of the data, summarizing the data, did they find that there was an effect? Yes. Participants receiving the LMFS, the LFMS, I should say, reported improved mood. The others did not. So the conclusion, what did they conclude? There you go. The LFMS treatment has a positive effect on those patients with depressive or bipolar disorders. Good. Okay, so the next thing we want to talk about is we want to look at experiments versus observational studies. Both of them are an attempt to try to compare two things. In an experiment, we create conditions. I should say we create and impose conditions on groups. And of course, there is always the control group and then the active group or the study group that we're looking at. So this might be if we have a medication that we want to use to treat a condition. Maybe you want a new pill for your headaches, a new headache treatment. So you take people that report frequent headaches, you give some of them the medication so that when they get a headache, they take the medication and they report back how quickly that medication relieved their headache and how completely it relieved it. And then another group who still report frequent headaches and give them a sugar pill or something with no medical benefit in it and have them report back, whether what the benefits were, how quickly it reacted, and if it reacted, or how effective it was. An observational study is take groups that already exist and gather data from them. Now, observational study, a lot of people read that word observational, and they think that means you just sit back and watch. That's not necessarily so. You can go in and you can gather information, you can perform tests, possibly draw blood, other things. You don't just have to sit back and watch. But the difference is in an experiment, you create the groups. In the observational study, the groups already exist. So looking at the two examples we've done so far, we had the steroid use example, and we had the depression slash LFMS study. Which one of those was an experiment? Okay, and why do you say that was an experiment? Okay, yeah. The researchers decided who was treated and who was untreated. So they selected their groups of people, and then they divided them up randomly. One group got the treatment, the other group didn't. So the researchers created those groups. They imposed the conditions of the study. That's actually a second thing that could be brought up here is in an experiment, the researchers imposed the conditions on those in the groups. In an observational study, those people, those groups already exist. They have already imposed the conditions on themselves. So the steroid use then, is that an experiment or an observational study? Observational, very good. In this study, the groups had already decided. They had already used steroids or not. The main reason a study chooses one or the other is usually, back to that word I bring up a lot, ethics. Would it be ethical to pick a group of people, divide them up, and give one group steroids and the other group a placebo? Go ahead. Well, yeah, medically, because we know that the effects of the steroids could be very harmful to the person receiving them, it would not be ethical to perform an experiment where we know that one of the treatments could be very harmful to the person receiving it. And the harmful effects of steroids have been proven. Exactly what they are is maybe we're still doing more research on. But the fact that there is a harmful effect has been proven through the years. One of them is definitely we've proven that there's a decline in natural testosterone production if you use steroids over the long term. So there is still harmful effects no matter what. So to intentionally give a group steroids would not be ethical. So you have to look for people that have done it on their own. When it comes to any sort of research on long-term illegal drug use, and in this context, steroids was an illegal drug because it was not prescribed by a doctor. It's very difficult to take a group and give them that illegal drug and then test the effects on them because you're forcing them or you're pushing them to do something that is known to be harmful to them or against the law in that case. Now, another decision is usually the availability of existing subjects. You might not be able to find people that have already done these treatments, so you may have to find some way to get special permission or find some way to test this where it is ethical and you can impose those conditions. That's where in a lot of cases, and of course the ethics of this is arguable and we're not going to get into that, where animal testing comes in for a lot of medications. A lot of new drugs are tested on animals with similar body chemistry to humans. They're not testing to see if the drug is effective in most cases. What they are testing to see is if the drug has any serious harmful side effects. Now, one of the advantages of testing on animals, lab rats are the most common one to use, and it isn't necessarily that lab rats are so close in biology to humans. They are still mammals, which makes them close to some extent. But one of the advantages of lab rats is the shorter life cycle and the more rapid turnover in generations. So lab rats normally only live for a few years. So by studying them, you can see the longer term effects of the medication might have on them. You can also, because of the rapid turnover in generations, you can also see if there are any potential birth defects in the next generation after having received that medication. So there are a lot of advantages. They said the ethics of animal testing we're not going to get into because that's a very heated topic and not one that you can really come up with a definitive answer. So we're going to stay out of that. But there are, like I said, a lot of reasons why you would have to perform one or the other. Most medical tests, by the way, end up being a combination of observational study and experiment. But before it actually hits the market, there is going to be an experiment done. Most medications, they will take a group of people that have that illness and get them to volunteer to either take that medication or a placebo. Sometimes rather than a placebo, they're testing them a new medication versus an old medication to see what the effects are. Now, we looked at that scientific process here. And we did ask the question. And I'm going to greatly abbreviate it. We asked the question here, what is it we wanted to learn about? We decided how to measure the data. Decide how to gather and measure data. I'm going to give myself a little space here. We looked at summarizing and analyzing the data. And we looked at conclusion. If this were a formal statistics class, these steps would be a little bit different. In a formal statistics class, the question is actually formed in terms of hypotheses. What do we think is going to happen? We don't just ask a question. What's going to happen if we do this? What is going to happen if we put people in this machine that emits the low frequency magnetic stimulation? We're going to say, hey, low frequency magnetic stimulation will have an effect or will not have an effect. We give that statement, and then we'll gather the evidence to support or not support that statement. So then we might decide how to gather and measure data. This usually gets split up into a couple of different pieces in a statistical process. First is setting the parameters. You have to set what are going to be the parameters of the study, what are going to be the conditions, what type of analysis are you going to do. In statistics, there are a few different types of analyses you can do to compare things, depending on what type of information you have. How are you going to gather it? This would also be, selecting the samples, which we kind of glossed over in this group, in these examples we've done. Then the third step is to actually gather the data. And then the fourth step, is very similar to the third in our scientific method. The fourth step is then to analyze and conclude and make a decision. But the analyzing the data is a lot more complex than what we made it out here. It showed there was evidence, but remember we had said before that when we make those hypotheses, that when we display data, you always make assumptions against your own best interest. So you're going against yourself. So let's say you have developed a new medication to treat a certain illness. You are going to assume that the current medication is more effective than your new medication. And then when you gather information, you're going to gather information that makes it so highly unlikely that that's true that you have to then decide that your new medication is actually better. So that's part of that analysis is even if your medication is better than the old one, or does have results that are better, is that part of a true result? If more patients are cured from your medication than they were on the old medication, is that a true result saying that your medication is better, or is it just random chance? Did it just happen that the people that were chosen to be in the sample for the new medication were people that were going to get better no matter what medication they took? So then from that, then you do still make your conclusion. So for those of you going on to statistics, this is the part, this analysis and conclusion, that's the difficult part, because like I said, your number may be bigger than the other number, but is it enough bigger that we can say that we're sure that it really is bigger, and there's no way it could just be random chance that it came up with a larger result. Okay, so we've looked at the observational studies and we've looked at experiments. And hopefully you guys have a little bit of an understanding of when you would use which one. The next thing I want to talk about more is the cause and effect. So the cause and effect relationship is something we discussed a little bit when we did modeling. Just because we could graph it and get, a line on the graph, and we could get an equation that describes it, y equals mx plus b, where m is the slope and b is the y-intercept, that starting point. Just because we can graph this and get that equation doesn't mean that whatever's represented by the x variable is the cause and what's represented by the y variable is the effect. They might both be caused by some third thing that causes them to change together. So the question really comes down to is, do we care? So if we look at the first study, the steroid use, there are a couple of possibilities here. One possibility is the steroid use caused an enlarged amygdala. Amygdala is just part of the brain. The second possibility is those people already had an enlarged amygdala, and that made them more prone to steroid use. Maybe having the enlarged amygdala makes you more sensitive to testosterone levels. Maybe having the enlarged amygdala makes you more, for some reason, body image is more important to you because of that or whatever. So it's possible that the enlarged amygdala could cause the steroid use. So the question here is, do we care? Does it matter in this one which way it is or not? Does it affect the validity or the importance of this study? If the steroid use caused the amygdala to be enlarged, or if the people already had an enlarged amygdala that caused them to be more prone to steroid use. What do you guys think? Let's narrow it down. Part of it comes down to the purpose of the study. Go ahead. Go ahead, Sam. Yep. Well, let's see if our purpose here is to show that steroids are bad for you. So the purpose of the study is to show yet again that steroids have a bad effect on you. If this were true, does it support that statement that steroids are bad for you? Yes. If this were true, does that support the statement that steroids are bad for you? Well, the enlarged amygdala caused the steroid use. Yeah. It's not showing that the steroid use had any ill effects on your body. The ill effect was already there, and it caused you to be more likely to use steroids. What if the purpose, rather than to show that steroids is bad, what if the purpose is to predict a tendency to use steroids? If that were the purpose, then which one would actually be a significant result? If you're trying to predict the likelihood that someone was going to possibly become a long-term steroid user, if we scan their brain and if it really was true that the enlarged amygdala made them more prone to it, we could scan their brain and all the people that had enlarged amygdalas, we could coach them on avoiding steroid use or whatever in order to predict they're the high risk population. So yeah, it does make a big difference which one is true or not. Depending on what your purpose of the study really is, I guess, in that case. Well, let's look at the other one, the low frequency magnetic stimulation. Now, there's a possibility that the LFMS improved the mood or there was some other cause. If you looked at that article carefully, there was a side effect. Does anybody remember what that side effect was of the LFMS? It was short-term what? Okay, I was thinking they said short-term memory loss was a possible side effect. Let me go back and take a peek here. Gotcha. They were talking about more of the electroshock therapy caused the short-term memory loss. So you are correct. So that one doesn't come into effect there. If that were an effect, if that were a side effect, if it came down to it, like short-term memory loss or whatever, their mood improved because of the memory loss. They couldn't remember what they were upset about. Does it really matter? Either way, it improved their mood, right? So sometimes correlation is just as important as causation. In the steroid use case study, showing that the steroid use caused the enlarged portion of the brain, the amygdala, is important because they're trying to discover physical side effects of the usage. In the treatment of depression and bipolar disorder, they don't care whether it's caused or correlated. As long as people that receive this treatment show improvements, they don't care what the relationship really is. They just care that there's an improvement. Okay, now there is a third study out there. on abused children and then future homelessness. And that one is actually a link online. And because we're down to just a few, about 15 to 20 minutes left here in class, let's kind of go through this kind of quickly. Here's a case where you have child abuse and future homelessness. And what they're saying is the child abuse, people that were abused as children have higher rates of homelessness as adults. So my question I want to put out there for you, the study showed this. Do you think this is a case where one causes the other? Actually, rather than saying doesn't cause another, I want you to make the argument, just kind of think about what would the argument be for causation, that child abuse, being abused as a child, does make you more prone to be homeless in the future, or is it a correlation? In other words, yes, being abused is people that are abused as child do have higher rates of homelessness later on, but the homelessness isn't caused by the child abuse. There's something else. There's a third factor that causes both of them. So I want you to just think about that for a couple of minutes, and we'll discuss them in about 2 minutes. So what'd you come up with? Let's just kind of go around, have each of you give your opinion here. I'm going to start with you, Sam. What do you think? Causation or correlation? And kind of give me a reason why. Okay. Okay, very good. Not every child that's abused is homeless, and not everybody that ends up homeless was abused as a child. Now, you mentioned drugs and other cause of homelessness. Is it possible that being abused as a child makes you more likely to be on drugs and therefore more likely to be homeless? Yeah. Okay. And when we look at causation, it doesn't necessarily have to be a guarantee. It just has to significantly increase the odds. The next thing we'll talk about is bias. And this study, to me, showed some definite biases. Bertie, you kind of voiced your opinion. Jocelyn, what do you think? Do you think this is a case of causation or correlation? Oops, okay. Well, I mean, it's very, it's one of those, it's a gray area. Being abused as a child could lead to higher rates of drug use. It could lead to higher rates of mental illness. I mean, it could lead to being put in foster care, which I'm not saying being put in foster care makes you more likely to be homeless as you're an adult, but there are things that child abuse, being abused as a child, could definitely be considered a trigger for many other possible things. They could be an intermediate cause of being homeless. As you said, drug abuse or drug use might make you more likely to be homeless. Mental illness, there's been several studies done that show the rate of mental illness among homeless people is extremely high. People that have been in foster care or whatever, have been removed from their home and been in some sort of state system are less likely to complete college, less likely to have productive jobs. So that might lead to higher rates of homelessness. So it could be a cause. It could be that the effects of being abused as a child lead to steps that do eventually lead to being more likely to be homeless. Now, again, it doesn't have to be definite. It doesn't have to be that everybody who's abused ends up homeless. It just has to be causation, just means it increases the likelihood. Significantly increases the likelihood. Now, the other side of it could be there have been studies done that show rates of child abuse are much higher in homes that are experiencing poverty or homes that are experiencing financial difficulty. So it could be that being in poverty, causes you more likely to be a victim of child abuse. And of course, being raised in poverty very, very well could also lead to being more likely to end up homeless as an adult. So here's a key, that correlation means there's a third item that influenced both of them. That third item makes it more likely for both to happen. Doesn't mean that it's not significant that, being abused as a child still makes it more likely to be more homeless in the future, but it's not a cause. It's the thing that causes the child abuse also causes the increased rate of homelessness. And again, don't have to be definite or complete. It just has to significantly increase the likelihood. The last thing I want to talk about here in the last 10 minutes is bias. And bias can be done in a couple of different ways. It can actually be done in preferences of the researcher. In the child abuse and homelessness one, looking through it, I had a strong feeling that the person performing the study really, really wanted to show, there's several times they stated that a large majority of homeless people were abused as children. They didn't put a number on it, but they made that statement. And that is one clue that there is a preference of the researcher, a bias in the researcher, is lack of specific numbers. If they just say a majority of those who are homeless report being abused as a child, well, is a majority 80% or is it 51%? Another bias could be systematic. When you're looking at a systematic bias, is it how the data was gathered? If I wanted to do a survey on public opinion on the importance of going to school after high school, well, if I went to a local college and interviewed people in the hallway, chances are they're going to say that they view schooling after high school as being important. Well, there's a bias there because of the way I gathered my data. I made it more likely that somebody with a certain opinion was going to be in my sample. The example that's given in the book is a coffee survey. They surveyed and they stated, I don't remember the number they gave here now. They're saying 45% of pedestrians in this city are carrying coffee. Well, if you look at the details of the study was done in downtown area, and between the times of, well, it just says it's 7:30 a.m. I read it at one point, it was 7:30 to 8:30 a.m. If we're looking at that, could these conditions affect, well, it's obviously it could affect it. First of all, how could the time affect it? Why is 7:30 to 8:30 in the morning important as a possible bias? What would cause that to bias the study? Do you think that rate would be the same if this study was done at 1 in the afternoon? Why not? People drink coffee to wake up. That's the time early in the morning is generally when people have to have that cup of coffee to function. So they're more likely to have coffee in the morning. Good. How about downtown? Do you think that would have an effect? That's exactly what I was looking for there. Coffee shops. If you're in a suburb, you're not going to have those coffee shops. One of two things is going to happen, right? You're either going to make coffee and have your cup of coffee before you leave home, or you're going to have to drive to work and you'll stop at a drive-through, grab your coffee and drink your coffee in the car, but you're not going to be walking down the sidewalk. Okay, so we've only got about 6 minutes left. Let's wrap this up here. As you can see, there's a lot of complications when gathering data. It's very important to be careful how the data is gathered. And some of the things that we talked about are selecting the sample. You need to make sure that sample, first of all, is random, that it's large enough to get some valid data from, but also random so that you're not putting people, if you're doing like a medical testing or whatever, you're not putting people with a higher chance of recovery in one group and lower chance in the other group. It's not good. It's not going to give you accurate results. The other thing is, we talked about that placebo effect. What this really comes down to is treatment. You need to make sure you don't treat one group different than the other. If one group knows they're not getting any treatment, if they know they're the control group, it might affect the results. So hence, like for the LFMS study, they actually put their head in the machine and zapped them and turned the machine on for 20 minutes without zapping them, so that they thought they were getting the treatment. And then finally, bias. Bias and how it is done. Have you done things to intentionally or even just subconsciously affect the results of the data? Okay, so your assignment, I want you to work on the out-of-class exercises for, I don't know why I keep saying P, for S3, and then the PNL, preparing for next lesson for S4. Those are going to be due I'd like to have them done for class on Wednesday, but you don't have to submit them until Thursday of this week. And remember the stuff that I'd asked you to do for today, the OCE from S2 and the PNL to prepare for today for S3, those need to be submitted by tomorrow, Tuesday. Now, some of you I know have had problems on the Pathways website on Canvas and have been doing your homework, printing off your homework and doing it on paper. You need to make sure you get that sent to me because I haven't got much of that yet. So I want to make sure I get the grade books updated for you here soon with only a couple weeks left. I want to make sure you know exactly where you're sitting. Okay, well, with that, we're done for the day. So have a great day and we'll see you all on Wednesday.